Hello everybody and welcome to .NET Conference 2022. Today I'm here to talk about .NET 7, Docker, Kubernetes and Azure DevOps, and I'm going to show you how you can create .NET 7 applications, how you can Dockerize them, and how you can deploy them on Kubernetes, and finally how you can create continuous integration and continuous deployment pipelines using Microsoft Azure DevOps. My name is Farahmanyan, international speaker and author, and currently I'm working as a CEO at Iranian Sputa company. In order to create or run .NET applications, or in order to create .NET projects, we have different methods to create our applications. The first one is using the Microsoft Visual Studio IDE, or the second one is to use the .NET CLI. If I'm going to use .NET CLI, in order to create new projects, simply I can use a new command and say .NET new, and I'm going to create web app using .NET 7 framework and put my project's output in the sample directory. By default, my project's names will be the same as this output directory. And finally, I'm going to use C# as my language. As you see, we have web app here in our new command. Web app is our project type. However, I can use other project types too. For example, I can use console application. I can create console application using the console keyword here, or I can create WPF applications, XUnit applications, and many other type of applications, Angular, React, Redux. The second part of this command is the framework part. I'm going to create my project using .NET 7 framework. However, you can use other framework types too. The third part is our output directory. And as I mentioned before, by default, the project's name will be same as this output switch. And the language I'm going to use is here, is a C# language, and I can use other languages such as Visual Basic or F# too. After creating my applications, obviously I might need to run my application. In order to run the application easily, I can use run command and say .NET new and pass my CS pass to the project switch of this command. After running this command, my project will start running. I can see my output. And finally, after running my applications and testing my application development machine or on my local machine, I might need to publish my, for example, web applications and host it on the, for example, on the web servers. In order to publish my applications, I can easily use publish command and say .NET publish, and then pass my CS proj as the command line argument to this command and say that I'm going to publish my application using the release configurations. After creating the application and publishing it, the second question arises here, and that how can I Dockerize my applications? How can I Dockerize my .NET applications? Okay, I know how I can create my .NET applications, or I know how can I publish my applications. So let's see how we can easily Dockerize my .NET applications. In order to Dockerize the applications, at the first step, I need to create a Docker file for my applications. In order to create a Docker file, we have again different methods. The first method is building the applications inside the Docker container, and the second method is to build the application outside the Docker container. Of course, my preference is to use method 2, or the second method, and it's really nice and have a great performance if you are going to use CIC. This second method is really fast, as it's going to build the artifacts outside the Docker build steps, and also it has very smaller size than the first methods. And if you are going to use a second method, the final Docker image will be thinner than the image that's built using the first method. Okay, let's Dockerize the application using the second method. If I'm going to Dockerize my application using second method easily, I can use from command in my Docker file. Using the from command, I'm going to say which image I'm going to use during my inside my Docker file, and then I'm going to say, okay, copy the output of my application, which is located at bin/release/$7/publish, copy to the app folder, and then switch to app folder using workdir command. And finally, I'm setting the entry point and saying that which file or which point is my entry point to application, and the application could be sourced from that point. If you see this very small Docker file, we have mcr.microsoft.com at the from part of the Docker file. The mcr.microsoft.com here is our container registry. The second part of the from is the .NET keyword here. That's our container repository. The third part is ASP.NET. That's indicating the container image name. And the last part is 7, which is the image tag that's used while pushing this image to the Docker repositories. So easily, we know how we can Dockerize the application using these 4-line commands. Easily, using the from parts, I say which image I'm going to use, and then using copy command, I'm going to copy my file from a local machine size Docker image, and then switch to that folder, and then saying my entry point to start my application. It's really easy. As you see that with a few steps, I create the Docker file for my applications. After creating the Docker file, the second step is to build a Docker image. In order to build a Docker image, simply you can use Docker build command. Docker build command has a very important switch, which name is T or -T. In fact, it's my image name. And I'm going to say, so, okay, Docker, please build my image and name it my sample. And in order to build this image, please use Docker file -F or F switch here is used to show where is my Docker file located. So easily using Docker build -to my sample -F Docker file. And as you see, we have a dot at the end of this command that's showing off us the context of our image. So using Docker build, I can easily create my image or building my Docker image. As you see, the -T here is the image name, and also the Docker file, that is my path to Docker file, and the dot at the end of this command is my context. After building the image, I need to run the Docker image in order to test it and see if that's still working. In order to run the Docker, I can use Docker run command. Switch D here, or -D, shows that run the application in the background. Switch P is very important in running Docker image. It's for ports mapping here, and it's used to connect external port to internal port. The left hand side is our external port, the ports that we are going to use in our, for example, in our browsers to browse my applications. And the right-hand side is the internal port that's inside my image. So I'm going to map this external port, that internal port inside the image. The other part of Docker run command is name switch or --name. The first parameter of --name is my container name. I'm going to create a container and name it my sample container. And this container is going to be created using the my sample image, which is built at the previous step. After running the application using the Docker command, I might need to view my web page running from a container, for example, in my browser. So up to here, we understand how to create Docker application and how we can easily Dockerize them. The next step is to understand how we can deploy them on Kubernetes. In order to deploy them in Kubernetes, very important step here. If you are using the Windows operating system, or if you are using the WSL, you might start using Docker Desktop. And if you are using Docker Desktop, the first steps you might need to enable Kubernetes in the Docker Desktop. In order to enable the Kubernetes in Docker Desktop, easily you can go to the settings section in Docker Desktop and then navigate to Kubernetes in the left-hand side menu, and then click on Enable Kubernetes. After clicking this Enable Kubernetes, it might take some moments to enable the Kubernetes and downloading the required image. And after that, your Kubernetes will be enabled and starting in your machine. And if you are not using Windows operating system, you can or you might need to download Kubernetes, or you might need to configure Kubernetes and start the Kubernetes service on your, for example, Linux operating system or any other operating systems that you are using. If you do a search in the market, you might face with different Kubernetes tools. For example, you might find the Minikube for your testing environment, and we have many other tools in the market which might help you in using Kubernetes in your different environments. However, in this session and in this talk, I'm not going to use any externals tools except Kubernetes itself. After enabling the Kubernetes, I might need to create a file defining Kubernetes resources. It's very similar to the Docker Compose file in the Kubernetes resource file. There's some important parts. The most important part of Kubernetes resource file is its replica section that's used to say the number of replicas I'm going to run. For example, here I'm going to say that I have one replica, and with these settings, when I'm going to source my container, I will see that the only one container is running in my Docker desktop. And if I increase the number of replicas here, my applications will be somehow load balanced with between different replicas. The second part of the Kubernetes resource file is a container name file. It's used to name the container. So using this Kubernetes resource file, I'm going to create a new container named my sample. And this container will be created using my sample image that's built at the previous slide. And the other important part of the Kubernetes resource file is the port mapping section. I'm going to map the port 1100 to port 80. The 1100 is my external port, and the 80 is my internal port, which we talked about at the previous slides while we started the Docker. We use the Docker run command, as you might find out. We use this port mapping, that command too. So in the production environment, we're not going to use Docker run anymore, and we will only build a Docker image and then pass the running part to our Kubernetes and deploy the image in the Kubernetes. So the Kubernetes will be responsible to running our applications. So setting the external and internal ports mapping will be essential in our Kubernetes resource file. After creating a file defining Kubernetes resource, we need to create or update our resources very easily. In order to create and update the resources, I can use kubectl apply command. Kubectl apply as an argument or as a switch that's named as -f switch. -f, again, like the Docker build command, is used to pass the Kubernetes resource file passed to the apply command. So kubectl apply -f kubernetes.deploy.yaml. I'm going to say the Kubernetes that please apply the change inside deploy.yaml file. Very easily using this one-line command, I can deploy my application on Kubernetes. And as you see, it's really easy to Dockerize my application and deploy it on Kubernetes. It's really easy, and I'm going to show you in the practical too. And finally, in order to create the CI/CD pipeline in Azure DevOps, we have two different steps. First, to create our continuous integration pipeline or create build pipeline. Very easily, I can create my build pipeline. The first part of my pipeline is to publish my .NET applications. As I mentioned before, I'm going to use the building application outside the Docker image. So the first part of the build pipeline is to publish my .NET application. And the second part of the continuous integration pipeline is to build the Docker file. As you see, I'm going to use command line tool here and execute the Docker build command inside my build pipeline. The Docker build command is the same as the command which we talked about in the previous slides. After running this pipeline, my image will be created and automatically will be shown in my Docker desktop too. After creating the build pipeline, we need to create a release pipeline. As you see in the build pipeline, we created our Docker image file. So obviously, the second part, or the release pipeline's responsibility will be to deploy this image to our Kubernetes. At the previous slides, we found out that in order to release our Docker image on Kubernetes, we need to use kubectl apply command. So I create a release pipeline and add a PowerShell command to my pipeline, and then I'm going to execute the kubectl apply command inside my PowerShell task inside my release pipeline. Easily, I created my release pipeline. After running my pipelines, I will see that my image has been created and will be shown in image section in Docker desktop. And if I'm going to switch to the container part of Docker desktop, I will see that a container named my sample has been created in Docker parts too. As you see, there are some prefixes and postfixes to my name here too. It's because of managing the replicas name and their random strings that's added to my container name. Okay, as you see, that's container created by my continuous delivery pipeline. As you see, it's a really simple approach to Dockerize and deploy application on Kubernetes. You might need to do some further work in order to fully work this solution in your production environment. You might need to use private or public Docker registries and push your Docker image into that private or public Docker registries. Or you might need to use Kubernetes namespaces, or obviously you might need to use Azure Kubernetes services, K8S, to manage your Kubernetes, or you might need to use multi-stage pipelines and create one pipeline, one YAML file pipeline, and put your build and release pipeline both at the same pipeline and use the multi-stage pipelines. Finally, if you need to get access to source codes of these sessions, if you need to get access to this session source code, you can navigate to azure.com/faramania/git and .NET Conf 2022, or you can navigate to my GitHub profile page and find the .NET 7/Docker/Kubernetes repository, and all the source codes and the presentation files are you can find them in that repository. In order to contact me, you can use paramendian2011@gmail.com in order to send me your email, or you can connect me at Twitter using _jinget handle, or you can find me in GitHub using Faramedian ID, Instagram using Faramedian, LinkedIn Faramedian, also YouTube using jinget.net, and you can ask me any question you have related to these sessions, and I will be answering your question that social media. So after presenting my presentation, let's see how our codes are going to work. First of all, let's get back to the terminal. Here is my project located, and let's see what's inside this folder. As you see in this folder, I have my sample CS proj file, I have my Docker file here, and also I have my Kubernetes deployed at the YAML file. And if I open the Docker file, I will see that inside the Docker file, I'm going to use from mcrmicrosoft.com/.net/h.net7, and I'm going to copy bin release.net publish folder to the app folder, and then switch to the app folder and configuring my entry point. This is my Docker file. Before starting anything, let's delete these bin and obj folders, okay, and then get back to the terminal. Without doing anything, I'm going to use docker build command here, and I'm going to say, okay, docker build my image and name it, for example, my sample image, and the Docker file is located at the root of my project, and the context is that. If I execute this command, an error will be arises. Let's execute it, and as you see, I have an error here saying that the copy this folder to this folder failed. Why it's failed? Because I do not have any folder at this path. As I told you, I'm going to build the application outside the Docker image file. So before building the Docker image, I need to use .NET publish command, .NET publish, and use the sample CS proj, and also publish my application in the release configuration. Okay. And we're waiting to publishing to finish publishing my application. Okay. And again, use the dir. Okay, I have my bin folder here. Let's see what's inside my bin folder. There's a release folder inside the bin, and also there is a folder named .NET 7 inside it. There's a folder named publish inside it. And if I view the contents of the directory, I will see that my application's output is located here. Okay, let's clear the screen again. And now I can run the docker build command. Docker build my image, name it, for example, my sample image, and use the Docker file as my Docker file, and config status 0. Okay, now the Docker image has been created. I can get back to the Docker desktop and go to the image section. Oh, there's an error occurred. What's the error? Docker build my image using Docker file. Failed to solve with front Docker file. Failed to read Docker file. No such file or directory. Okay. I'm inside the publish folder. I need to get back to the root of my project. So my Docker file is located at the root of my project. So let's get back to here. Yes. And use the directory command. Yes, my Docker file is located here. I can use the Docker build command now. It starts to building my Docker image. Okay, my image now is created successfully. I'm going to Docker image, and I see that my image created here. Name it my sample. Less than a minute ago, my image created, and it has some size. It's my image size. After creating the Docker image, easily I can use the kubectl apply in order to deploy my application on Kubernetes. kubectl also asked me for the Kubernetes resource file. As you see, Kubernetes resource file again is located at the root of my project. You might find it useful to move your Kubernetes resource file outside your project. It's okay, and you should be aware that while using kubectl apply command, you pass the appropriate Kubernetes resource file path. Okay, let's try it. kubectl apply and use the Kubernetes deploy.yaml file. Okay, here's an kubectl apply. The deployment file created and service started. And let's get back to Docker desktop. My image changed to in use, and if I go to the container section, I see that there's a container here named my sample, and it's starting to servicing. Let's get back to my Kubernetes deploy YAML file and watch what's going inside it. I'm going to create one replica of my application. I'm going to create a container named my sample. I'm going to use image, which is name is again my sample, and I'm going to map port 1100 to port 18. Okay, let's open my web browser and navigate to localhost 1100. Okay, my application is up and it's running. Let's close the browser and get back to the kubectl resource file, and let's change it. And I'm going to increase my replicas to 3 and save it. After saving the resource file, I can again use the kubectl apply commands to update my Kubernetes. Okay, it's reconfigured, and if I get back to Docker desktop, I will see that I have 3 different sample images here. 1, 2, 3. These 3 are my Kubernetes applications. It would be nice to try. For example, let's stop one of my images in one of my containers. As you see, when I stopped my container, Kubernetes automatically starts other container in order to support my 3 replica applications. Okay. This is how our code and how our process is working locally. Let's get back to the Microsoft Azure DevOps. In Azure DevOps, I've pushed my codes to Azure DevOps repository. I can find my files in the Azure repo section, files menu. Let's open it to view the files inside it. Okay, here's my file, my sample, my Kubernetes YAML file, my Docker file. And also let's get to pipeline section and open the pipeline. This pipeline is mainly my build pipeline. I'm not going to use multi-stage pipeline. However, in the production, you might need to use a multi-stage pipeline in order to have a very simple sample of the approach. I prefer to separate the build pipeline from release pipeline. Let's open the build pipeline and view its content. During this build pipeline, as I mentioned before, I'm going to only publish my .NET application and I'm going to build my Docker image. Let's open it in a new tab. Okay, here is my build pipeline. As you see, I have a .NET Core CLI task here, which is responsible to publish my .NET application, and also I have a command line task, which is responsible to build my Docker file. And the other part of my pipeline, I use to copy the outputs to my artifact staging directory and then publish my build artifacts so that my release pipeline can access the output of build pipeline. This is my build pipeline, and if I get to the release part of the Azure DevOps, I will see my release pipeline here, and let's edit it. Inside the release pipeline, I have one environment named sample env. It has one job and one task. If I get inside it, I see that I have a deploy to Kubernetes task, which is basically a PowerShell task. Inside this task, simply I'm going to use kubectl apply command. After running this build and release pipeline, again my Docker image will be built and pushed to the Docker desktop, and also the deployment to Kubernetes will be succeeded. But before starting my pipeline, let's delete the Kubernetes resource from my system. In order to delete the resource easily, I can use kubectl delete command. After executing this command and getting back to the Docker desktop, you will see that your Docker image has been deleted, and the image, my sample image, which was in use mode, it has been get offline. Okay, let's delete this image. Okay, now I do not have any image named my sample. I do not have any container, and I can delete these pod containers too. Okay, it's very clean now. Let's get back to the build pipeline and start running the pipeline. And run the pipeline. Okay. And it starts, my build pipeline starts creating the applications. First, it's checking out my source code, it's publishing the application. Okay, and then building the Docker image, as we talked about, and then copy files and publishing the build artifacts. At this stage, if I get back to the Docker desktop, I will see that my sample image has been created here. And let's get back to the Azure DevOps and go to the release pipeline. You will see that release pipeline has been started automatically. There's some seconds of delays where it starts automatically after releasing my application. It starts the releasing. It's waiting the agents to run the task. Task is already queued inside the agent. Let's open it and see the details of agent. Okay, it's running and the release is in progress. It downloads the artifacts and then deploy to Kubernetes. And if I get back to Docker desktop, I will see that the container created and is up and running. And then get back to my browser and browse the localhost 1100 again. Okay, my application is up and it's running. As you see, it's really easy to Dockerize the .NET application and deploy it on the Kubernetes. And also, it's really easy and straightforward to create CI/CD pipelines. If you need to access the source codes of this presentation and source of this presentation, you can navigate to my GitHub page, as I mentioned in slides, at the github.com/verifier/.NET7 Docker Kubernetes. I hope you enjoyed this talk.